All right. What we are looking at today is we're going to look at making the graphs of these sine and cosine functions. So when you came in at the beginning of the hour, I asked you to find the sine and the cosine of some special angles. Okay. Does anybody have the sine of negative 90? Sine of negative 90. Yep. Negative 1. Very nice. How about the cosine of negative 90? 0. I love it. All right. How about the sine of 0? 0. Okay. What about the cosine at 0? 1. All right. Now, if you had trouble with your angle, grab your calculator. Grab your calculator as a way to verify that what you did was correct. Okay, what about the sine at 90? 1. And what about the cosine at 90? 0. All right. How about the sine at 180? 0. How about the cosine at 180? Negative 1. Looking good. We're doing a great job. How about the sine at 270? Who had the sine at 270? Negative 1. How about the cosine at 270? 0. All right. What about 360? What is the sine at 360? 0. And how about the cosine at 360? 1. And 450. What did we have for 450? All right, sine is 1 and cosine is 0. Okay, now what we're going to do is we're going to plot these points. We're going to take a look at what they look like on our graph. So this is the graph for just sine, and this is the graph for just cosine. Okay, now I'm going to keep them separate here so we can tell the difference. All right, this is going to be my graph for sine, and my green is going to be my graph for cosine. Okay, so as I'm looking at this, let's plot our points for sine to begin with here. So at negative 90, I'm at negative 1. Okay, so I'm going to go left to negative 90, down to negative 1. At 0, I'm going to be at 0. At 90, I'm up at 1. At 180, I'm at 0. At 270, I'm at negative 1. And at 360, I'm at 0. And 450, I'm up at 1. Okay? Now, does it look like, what does it look like happens here? It is a wave. Sine and cosine graphs are wave graphs. It comes down, it bottoms out, it goes up, it turns back around, it comes back down, bottoms out, goes back up to the top, comes back down, and guess what? It continues on forever in both directions. Absolutely. Forever in both directions. Now, as we take a look at cosine, let's take a look at cosine. Okay, at negative 90 with cosine, I'm at 0. At 0 with cosine, I'm at 1. 90 with cosine, I'm at 0. 180 with cosine, I'm at negative 1. 270 with cosine, I'm at 0. 360 with cosine, I'm up at 1. And 450 with cosine, I'm back at 0. Does it have that wave shape also? Of course. Yes. Okay, so from negative 90, it goes up to the top, back to 0, down to the bottom, back to 0, up to the top, back to 0. And this one continues going on forever in both directions. Now, I got some questions here. Do they look the same?
Not really.
Do they look similar? What looks similar about them? Yeah, they both have that wave shape. In addition, that wave shape is contained between what? Yeah, the bottom is negative 1 and the top for both of them is positive 1. What is different about our graphs? Yeah, where they intercept 0. Where does sine start? Sine starts at 0, but cosine starts at the top. Cosine starts at the top, which is at 1. That's important. Okay, now, just a comment. When we go through this graph, notice that sine starts at 0. Okay? Sine starts at 0 here. When does it get back to where it started? Okay, so it goes from 0, it goes up to the top, it comes back to the middle, it goes down to the bottom, and it comes back to the middle. And it's right back where it started with. This is called one cycle, okay? One cycle. Where it started to where it gets to back to the exact same spot, okay? One cycle has a length that is called a period, okay? Now, obviously, the period of this graph, it started at 0 and it's got back to the same spot at 360 degrees. So the period of this graph is 360 degrees. Notice with cosine. Cosine starts at the top. When does it get back to the top? Yeah, it goes to the middle, it bottoms out, it goes back to the middle, and then it gets back to the top where it started from. Okay, the period is the length of one cycle, okay? So notice that with sine, it started here at 0, it goes all the way to the top, then it goes all the way to the bottom, and then 360 is like it starts over there again, right? That is a cycle, okay? One full cycle, and how long that cycle is what we call the period, okay? If I take this out, it took me 360 degrees to get me back to the start of this graph. Here, it started at the top, it goes all the way to the bottom and back up to that same starting spot on the top. It took me 360 degrees to get me through one full cycle of the graph. Okay? All right, now let's take a look. Let's take a look at our graph here. All right, so first of all, what's my domain? What numbers did I put in for x? Yeah, I mean, what about x's? I put in any number I wanted, right? I gave you the numbers, but we could put in any number we wanted. What does that mean about domain? All real numbers, absolutely. The domain is all real numbers for both of them. And remember, we can abbreviate that as the double-backed R. Now my range. What about my y's? What about my answers? Did I get any number out there for my answers? Yeah, the smallest answer I got was -1. The biggest answer that I got was +1. So my range is y is greater than or equal to -1, but less than or equal to +1. Y is greater than or equal to -1, less than or equal to +1. All right, now what about the maximum value? What's the highest number that I got on these graphs? +1. Good. What's the minimum value? What's the smallest number that I got on these graphs? -1. All right, what about my y-intercept? Where did this graph, where did sine cross the y-axis? 0. Where did cosine cross the y-axis? 1. This is important. Sine always crosses the y-axis at 0. Cosine always crosses the graph, the y-axis at the maximum value, at the top of the graph. All right, got that written down so far? All right, here we go. What is this all talking about? How do we put this into, how do we organize this information? Okay, we got some vocab we got to talk about. The amplitude, okay? The amplitude is half the difference, half of the difference between the max and the minimum. Between the maximum and the minimum. Difference means I'm doing what? Subtracting. Okay, so the difference between the maximum value minus the minimum value. The biggest to the smallest. Really, ultimately, it's the distance from the middle to the maximum or the minimum. The distance from the middle of my graph to the top or the distance from the middle of my graph to the bottom. Okay, periodic functions. Sine and cosine are what we call periodic functions. Now that means that it is going to be, they're going to make graphs. Each graph has a repeating pattern. A repeating pattern that continues indefinitely. And as I commented, your cycle is the shortest repeating pattern. It is one piece of the graph. Where do I get back to where I started? That's the cycle. All right, and the period of my graph? The period of my graph is the horizontal length. Horizontal. I'm looking on the x-axis. The horizontal length of each cycle. For sine and for cosine, for y equals sine of x and for y equals cosine of x, our period was 360 degrees. Now that's not always going to be the case, so we're going to have to figure out some ways to find it. But on this graph, the two graphs we just made, it was 360 degrees. All right, so far so good? Questions so far? All right, now let's take a look here. All right, y is equal to a sine of bx, and y is equal to a cosine of bx. Okay, so we have a number out in front, which is the a. The a is the amplitude. It tells us the distance from the middle of my graph to the top and from the middle of my graph to the bottom. Okay? The amplitude is the absolute value of that number out in front. Okay? My b value right here in front of my x helps me to find the period. The period is 360 divided by the absolute value of that b. Okay? The period is 360 divided by the absolute value of that b. Okay, now my 5 points. On my graph, I'm going to make 5 key points. Okay? They're going to be the maximums, the minimums, and the intercepts. Okay, so this is what sine is. Okay? Here's the deal. My amplitude is the absolute value of a. So from the middle of my graph to the top, it's a distance of a. From the middle of my graph to the bottom, it's a distance of a, so that is negative a down there in the bottom. In both cases, from the middle of my graph to the top, I go up a. From the middle of my graph down, I go down a. So I go from negative a to positive a. All right. Then the period. Okay, here's the deal. Hopefully we can see this. Isn't it true that my sine graph starts here, it goes to the top, back to the middle, goes all the way to the bottom, and then it goes back to the middle until we get back to where it started with, right? Yes, no, maybe? Okay. Now, this means that to this point, this is going to be the period right here. All right? Whatever we get for that 360 divided by the absolute value b, that's going to be right here. Really want to make sure you're paying attention to this. Getting this all down. Now, how far is this? Halfway. So this number right here is going to be half a p. How far am I right here? A quarter. So this is going to be a quarter of p. And how far am I right here? 3/4. So this is 3/4 of p. All right, now, same thing over here with cosine. All right, so cosine starts at the top, goes to the middle, all the way to the bottom, back to the middle, and then all the way back to the top, right to where it started. All right, now, from the beginning to the end of one cycle, this is the period. This is P. Now, right here when I'm all the way at the bottom, this is halfway, so it's going to be half a P. This right here is a quarter of the way, so it's going to be a quarter of P. And this one is 3/4 of the way there, so it's going to be 3/4 of P. Now, the 5 points that are important on my graph, I said are the maximums, the minimums, and the intercepts. Okay, so it crosses my x-axis here, here, and here. All right? Sine has a maximum up here, and it's got a minimum down there. Those are my 5 key points. Those 5 points have to be on my graph. All right, with cosine. All right, cosine only crosses the x-axis here and here. Cosine only crosses my x-axis there and there. But it maxes out twice at the top and the minimum there at the bottom. So these are my 5 points that have to be on every single graph. Fair enough? Questions with that? Okay. So far, so good? All right, let's see this in action. Let's see this in action. Okay, so we're going to graph one period of our graph. Y is equal to sine of 3x. Okay, so here's the deal. Above that, I want you to write this. Y is equal to A sine of bx. I know that I'm doing sine, so it's y is equal to A sine of bx. Now, what number is in there for A? 1. In front of this sign would be a 1. What number's in there for B? 3. Okay, now, here's the deal. Here's the deal. My A makes me think of amplitude. My A makes me think of amplitude. Okay, now my amplitude is the absolute value of A. My amplitude is the absolute value of A. So in this case, the absolute value of 1 is 1. Now on my graph then, if my amplitude is 1, I go from the middle of my graph to the top, it's 1 unit. And from the middle of my graph to the bottom is 1 unit down there to -1. So what's the maximum on this graph then? This graph's only going to go up to what? 1. What's the minimum on this graph? It's only going to go down to -1. Are we okay with that? Folks, you got questions? Any questions so far? This isn't easy. This isn't easy. Pretty messy graphs. Okay, now the period. The period is always going to be 360 divided by the absolute value of B. 360 divided by the absolute value of B. So I have 360 divided by the absolute value of what number do I have for B? 3. Okay, so what's 360 divided by the absolute value of 3? 120. Okay, so that means that from the start of my graph on the horizontal axis, I'm going to go out to 120 degrees. I'm going to go out to 120 degrees. Okay, now here's the deal. Here's the deal. My period is 120 degrees. I'm always got to find the places that come before that on my horizontal axis. And the way that I find the places that come before that, I'm going to take 1/4 times the 120, 1/2 times the 120, and 3/4 times that 120. Every single time. So what's 1/4 of 120? 30. Okay, what's half of 120? 60. What's 3/4 of 120? 90. Okay, so that means, okay, I'm up here, I'm going to go, okay, there's halfway, there's 1/4 of the way, there's 3/4 of the way. So there's halfway, there's 1/4 of the way, there's 3/4 of the way. Now what number is going to be underneath here, this first dash? 1/4 of the way there is 30 degrees. What's going to go under this halfway point? 60. What's going to go under this 3/4 of the way there? 90. Okay. All right, now we've got to make our graph. Okay, we got to make our graph. Now you got to always remember, does sine start at the top or does it start at 0, 0? Where does the sine start? 0, 0. Sine always starts at 0, 0. So all I do is I say, well, my first spot is always going to be at 0, 0. Sine goes from 0, 0 all the way to the top. Then it goes back to the middle. It goes down to the bottom. And it goes back to the middle. That's the pattern that it follows every time. It goes from the middle to the top, to the middle all the way to the bottom, and back to the middle. That's always the pattern for sine. We just know that. If you remember, right here, sine went from the middle to the top, to the middle, to the bottom, back to the middle. That's always the way it looks. It's always the way it looks for sine. So I know that my graph is going to be a wave arrows on both ends because we know it continues on and on forever and ever. That looks like that. Now, where are my intercepts? Where are the intercepts? Where does this graph cross the x-axis? Okay, don't forget, what's the first one? 0 degrees, then 60 degrees, then 120 degrees. All right, what about the domain? What about my x's? All reals. The domain is always all reals. What about my range? What about my y values? What's the smallest number I got for y? -1. What's the biggest number I got for y? +1. So my y's go from -1, less than or equal to y, which is less than or equal to +1. Are we okay with that? Yes, no, maybe? Yep, you know what? Let's do the last one, but I'm going to switch it a little bit, okay? Let's do C. Let's do C, but I'm going to switch it a little bit. Instead of making it 2 sine of 90x, let's change that. Let's make it y is equal to 2 cosine of 90x. All right, let's change it to y is equal to 2 cosine of 90x. So we want to remember, the first thing you want to do is right above that, you're going to write y is equal to a cosine of bx. Y is equal to a cosine of bx. Now, what number is in the place of a? 2. What number is in the place of b? 90. Okay, now a makes me think of what? Amplitude. A makes me think of amplitude, which is the absolute value of A. So the absolute value of 2 is 2. Okay, now on my graph, that means from the middle of my graph, to the top is 2 units, and from the middle of my graph to the bottom of this graph is 2 units. So this graph is going to go up to +2. This graph is going to go down to -2. All right. Now, to find the period. How do I find the period of this graph? Beautiful. 360 divided by the absolute value of b. Okay, so 360 divided by the absolute value of 90, which is 4. Yep. So from the start of this graph to the end of the first cycle is going to be 4 units. The period is 4 units. Now remember, I told you every single time we've got to figure out what else is on this x-axis. So I'm going to take 1/4 of 4. I'm going to take 1/2 of 4. I'm going to take 3/4 of 4. All right, what's 1/4 of 4? 1. What's 1/2 of 4? 2. And what's 3/4 of 4? 3. All right, so let's see. I go halfway to 4. I go 1/4 of the way to 4. And I go 3/4 of the way to 4. All right, now what value here is 1/4 of the way to 4? 1. What's 1/2 of the way to 4? 2. And 3/4 of the way to 4? 3. All right, now, cosine graph. Cosine graph. Where does the cosine graph start? What? At the highest value. Cosine always starts at the highest value. So the cosine starts at the highest, which is at 2, goes to the middle, goes all the way down to the bottom, goes back to the middle, and all the way to the top. Always, always, always. Top, middle, bottom, middle, back to the top. So my graph is going to look something like this. Making those waves. All right, so what's my maximum value of this graph? All the way up to 2. What's my minimum value? Goes all the way down to -2. What are the intercepts? Where does this graph cross the x-axis? 1 and 3. What about the domain? What numbers do we have for x's? Sine and cosine. All real numbers. And what about my range? What about my y values? What about my y values? Where are my y's on the graph? What's the smallest number that I have? -2. What's the biggest number I have? +2. So -2 is less than or equal to y, which is less than or equal to +2. All right, so far so good? Yes, no, maybe? All right, one last little thing we need to talk about. Now we're going to talk about how to write the equation in the form y is equal to a sine of bx. Okay? They tell me that the maximum is 2 and the period is 60 degrees. Okay? Now remember that the amplitude is equal to the absolute value of a, and remember that the period is equal to 360 over the absolute value of b. Okay? Now, if the maximum is 2, what is that telling me? The maximum value is 2. My graph goes up to 2. That is the 2, absolutely. My amplitude is 2, so the a is going to be 2. All right. The period is 360 divided by the absolute value of b, but what did they tell me the period is? 60. So 60 is equal to 360 over b. What do I do to start solving for b? Yep, denominator of my fraction is b. I'm going to multiply by b on both sides. So 60b is equal to 360, and divide both sides by 60. So b is 6. Okay, now, they know that we want the equation y equals a sine of bx. So y is equal to, what number do I have for a? 2 sine of, what number do I have for b? 6x. because they told me that it had to be signed.
Oh.
Yep, otherwise we wouldn't know. Otherwise we would not know at all. Questions with that? Questions with that? Okay.